Bismillahirrahmanirrahim. Students, I'm going to teach you about the gas laws and the assignment which I have uploaded on the Moodle. So let us start with the gas law. The reference material is from the book McMurray and Fay, which I have already shared with you. And in similar video, I have already uploaded on the Moodle. You can also watch the video as well. So I'm going to explain the gas law. Actually, these are the different variables. Importantly, the variables are the pressure, temperature, volume, and the number of moles. And the specific relationship between these four variables are called the gas law. So this you have already learned in the previous classes, but what is the new in this field is, let's start with the first law, which is the Boyle's Law. So the Boyle's Law is, the first is the relationship is very simple. That means the volume is inversely proportional to the pressure, but at constant number of moles and the temperature. So this is the very simple relationship and understanding. How can you verify the Boyle's law? That means if the pressure is, just look at this example. If the pressure is 1 atmosphere and the volume is 1 liter, so if you increase the pressure by 2 atmosphere, that means you are going to double the pressure and the volumes become half. That means half of the 1 liter, which is equal to the 0.5 liter. And similarly, you can go to the backward direction. Here, that means you have to release the pressure by half and the volume is going to be double. That means inversely proportional to each other. So this is all about the Boyle's law. So actually this we have already learned in the classes. There are two straight line equation. One is the with the intercept and other one is the without intercept. So this is the volume is inversely proportional to the pressure, and when you remove the proportionality sign, there will be the constant on the right hand side, and that constant is the K, which you can say this is the constant for the Boyle's law. So here the plus intercept and intercept here is 0. So this is the equation. Actually, it is written as y equal to mx plus c. Here it is represented b, but you can say it is a b or the c, but importantly it is the constant. So basically this is the equation without intercept, because the intercept is 0, and this is the relationship between the volume and 1 over p. And when you plot this one graph with these two variables, and then it is the straight line passing through the origin. And if you plot the volume versus pressure, and then it will be a curve, because when you increase the pressure, volume is going to decrease, or vice versa, you can say in the other way. So this is not the straight line equation, because straight line equation is V and X is the 1 over P. When you plot 1 over P, then it will give you the straight line. This is the all about the Boyle's law. So now move to the Charles law. Charles law is simply the volume is proportional to the temperature. That means when you increase the temperature, volume is going to increase, but at constant number of moles and the pressure. So there is the representation for the Charles law as well. Very simple. That means the pressure is constant. So when you increase the temperature from 200 Kelvin to 400, that means you are going to double the temperature. The volume is also going to be doubled, because the volume is proportional to the temperature. And so either you can move from by heating, or either you can move from right to left side by cooling this system. So again, there is the volume is proportional to temperature, and when you remove this proportionality sign, there should be the constant on the right hand side. That constant is called the Charles law constant. Again, there is no intercept, or intercept is zero. So the simple equation is y equal to mx. So when you plot the volume versus temperature, it will give you the straight line passing through the origin. That means it is the verification of the Charles law. And here you can see that it is not passing through the origin. Why? The reason is because this is the temperature in Celsius, not in the Kelvin. So because here the temperature is in Kelvin, and you can calculate the Kelvin temperature out of this graph. This is the importance of the Charles law. So the third law is the Avogadro law. Avogadro law is simply the volume is proportional to the number of moles, but at constant temperature and the pressure. So here, if we are looking about the variation between the two variables by keeping the other two variables remains constant. So this is the importance in all these three laws. So again, that means so there is a relationship between the volume and the number of moles. So again, the pressure should be the constant. So what is the changes? What are changes over here? You are going to increase the number of moles. That means you are going to double the number of moles. So by doubling the number of moles, the volume is also going to be doubled. So that means both are directly proportional to each other, and vice versa. By removing the gas, that means you can also by removing the gas mean you are going to decrease the volume of the gas, or by uh, adding the gas, that means you are going to increase the number of moles of the gas. Removing the gas is to decrease the number of moles of the gas, and by decreasing the number of moles of the gas, of course, there should be the decrease in number of the volume, because these two are directly proportional to each other. So this is the one of the examples. So importance of learning is the critical thinking, actually what is happening with the different variables. So let's start with the example. If the temperature is 250 Kelvin, number of moles of 0.140, pressure is 1 atmosphere, and what is happening with the A and what is happening with the B. So conditions are given here. That means temperature is going to increase, but number of moles are same, pressure is the same in case of the A. So do you think which law is going to be applied over here? That means that temperature is going to be increased. So this is the Charles law. So according to the Charles law, volume is directly proportional to the temperature. That means temperature is increased, volume is also going to be increased. So, but here you can also calculate how much volume is going to increase. So this is actually you need to calculate the ratio between the temperature. So 375 divided by 250, it is 1.5. So it is the volume is going to be increased by 1.5 in case of A. So because volume is proportional to the temperature. So if you look at the example B, what is happening here? The temperature is constant, but the number of moles are going to be decreased. That means are half of the number of moles of as compared to the initial. the initial number of moles were 0.140, and these are going to decrease by 0.07. That means half of the number of moles of the initial. So what is happening with the pressure? Pressure is going to be also decreased, and the pressure is also decreasing by half. So actually there are two laws are going to be applied in case of example B. So first is the number of moles are going to decrease. That means which law is going to apply over here? It is the Avogadro law. So according to the Avogadro law, it's the volume is proportional to the number of moles. So if the number of moles are going to decrease, the volume is also going to decrease. So number of moles here, it is written here. So having the, according to the Avogadro law, having the molar amount where half the volume. So that means it is the number of moles are half, the pressure will also be half. So for the this one case, the pressure is half. That means the volume is will be the double, because the volume is inversely proportional to the Boyle's law. The volume is inversely proportional to the pressure according to the Boyle's law. So by decreasing the pressure by half, the volume is going to be double. So here, according to the Charles law, the volume is going to be half, but according to the Boyle's law, the volume is going to be double. So what is the net change in case of B? There is no change, because there is half, and according to the it is going to be, yes, because the volume is going to be half according to the Avogadro law, but the volume is going to be double according to the Boyle's law. So there is no net change in the condition B with these applied parameters. So this you have to, this is represented over here. That means that the volume is going to increase by 1/2, and there is no change in the piston by according to the Avogadro law and the Boyle's law, because there is no net change in the volume with reference to the condition B. So this is the assignment I have given to you. In the similar way, you have to apply the three law, and you can decide which law is going to be applied over here. So this you have to decide, and you have to write down in detail about the condition, initial condition, and what condition are going to be applied over A, and what condition are going to be applied over B. So this is all about your assignment, and the reference you can take out of this example, which one is the 9.3. So the last point of this one, so you can merge all these three law, and you will get the equation. That equation we'll call a ideal gas law equation. So volume is inversely proportional to the pressure. According to the Boyle's law, volume is directly proportional to the number of moles. According to the Avogadro law, volume is directly proportional to the temperature according to the Charles law. So when you remove the proportionality sign, there will be a constant which is called the gas law constant on the right hand side. So if you multiply this one, so this will, the equation PV is equal to nRT, and this is all about the ideal gas equation. So in this lecture, I have explained you the different laws that which are the the Boyles Law, Charles Law, and the Avogadro Law. Their critical thinking about actually what is the influence of these variables, pressure, volume, temperature, and number of moles mutually, and then finally, what is the ideal gas equation, which is the PV is equal to nRT. This is all about the teaching about the gas law and your assignment. And I expect you will finish it on time and submit to me through your Google account, Moodle account. Thank you very much.